Let's see. Okay, population. Okay, example here. Population is 4,000 t equals 0. And it grows by 5% every year. Well, you can predict what your populations are going to be. Okay, so let me just ask you to do this. If the population is 4,000 and t equals 0, what's the population at t equals 1? That means the population after 1 year, which means a population after it's increased by 5%. Okay, well, a lot of you using the formula that says you multiply by 1 plus r raised to the t power. Now that actually skips a couple of steps in understanding why, but that's what it is. And r is your 5%. Okay. And got tied up in writing what I saw, because I was pleased to see it. It's actually 4,000 times that, right? So we're looking through the population. Well, t is 1. So the population p of 1, which means a population after 1 year, function notation, right? We're plugging in 1 for t. And that's 4,200. Now, some people also did it using the definition of percent, and that's also good. Okay. And you want to be sure you understand this. I'm going to say alternatively, 5% of 4,000 is 200. Population increases. By 200. To give us 4,200, right? And okay. Now, what's the population next year? Following this reasoning, the population after another year the population, which is 4,200, increases by 5% of 4,200. then by 0.05 times 4,200, which is equal to 200 and 40. So okay, yeah, again by 204, not 240. There's some extraneous conversation going on, please. Let's not distract everybody. All right. So the new population becomes 4,200 plus 204. And wait a minute. I don't know how I got 200. By 210. Okay. Because 5% of 4,200 is 210, not 4. So now it's 4,410. And you notice what's happening every time the population increases by 5%. Since the population is always bigger than it was last time, it's always going to make a bigger jump. Every year, you're going to have more addition. You're going to add more to the population. Because 5% of the bigger number is bigger than 5% of the original number, which was this, right? So we grew by 200 when the population was 4,000. We grow by 210 when the population is 4,200. And then we could take 5% of this, which is going to be 520.5 or 220.5, and add to that, and we could just keep going that way, okay? But what we do with this function is using P of t equals 4,000 times 1.05 to the t. P of 2 equals 4,000 times 1.05 squared. Okay. And if I've done my arithmetic correctly, that's going to agree with what we did here. Why is that? It's because of this. P of 1 is 4,000 times 1.05. P of 2 is P of 1 times 1.05, isn't it? Because you always get your new population by multiplying the old population by 1.05 when you're adding 5%. That's what it means. 1.05 means you get your population, 1 times your population, plus 0.05 times your population. That's just 1 plus 0.05 times whatever your population was. Well, P of 1 was 4,000 times 1.05. Okay. You get P of 2, you multiply P of 1, your population after 1 year by 1.05, which adds 5%. Please check your masks. Okay. So we have this. So we have two 1.05s here. We see that P of 2 is 4,000 times 1.05 squared. Now, if we continue the process, I'll write out one more step. P of 3 is P of 2 times 1.05. P of 2 is 4,000 times 1.05 squared times 1.05, which is 4,000 times 1.05 cubed. And by extension, we see that the number of 1.05s we multiply by is the number of years, because every year we multiply by 1.05. That's very important to understand this, because so many things, everywhere from science through finance, like compound interest, and you might recognize that if you know about compound interest. And since the curriculum in Virginia at least requires a course in finance and economics, I would assume that you would know compound interest, but I find that's probably not true. Okay, it's probably not covered because you teach it to people who don't understand it, mostly because they don't want to. Okay, anyhow, this is just like compound interest. And this generalizes after t years, it's going to be 4,000 times 1.05 to the t. And this is an exponential function. It's ab to the t. Where's my watermark? Hopefully. Okay. It's ab to the t, and let me go ahead and lower the camera a little bit, just in case. So A is 4,000. And B is 1.05. So this is an exponential function. The population grows exponentially as an exponential function. This is what exponential growth means. Okay. If you're investing $4,000 at 5%, you get exactly the same. If you're compounding your interest every year, $4,000 at 5% every year, there's how much money you're going to have. Okay. If you have a radioactive decay, or I prefer to use something more relevant, you have some kind of therapeutic drug, you know, you got something that is antibiotic. The antibiotic tends to be an exponential function, but this number is less than 1. Like maybe it's 0.95 to the t instead of 1.05 to the t, meaning you lose 5% every hour. Your body processes it, either neutralizes it or you excrete it or whatever. And you get that kind of function. These functions are extremely important in finance and science and in almost every area in which you might end up being educated. Okay, so the next assignment deals with graphs of these things. You know, how to graph it. The stuff I went over last time. So one last comment. Exponential functions occur when the amount that you add is some proportion of the amount that you have. When your growth, the amount of growth is proportional to your population or to your whatever's there, okay, or to your money. Okay. More money you've got in your account, greater the annual increase, right? So, important stuff to understand. Okay. Don't walk in front of the camera until I stop the recording.